So first of all, thank you for showing up, and thanks for the also for the Wing core members for showing up and helping during the way. What we're going to do today is basically create a React and a React web application that is running a Wing backend. The main place for us is for us to look at the information is the repo that I've shared. The main place for us to discuss about those things is our Slack channel, and in particular, this workshop channel. Let me again send the link here. And what we're going to do during the session is we're going to learn how to develop a Wing application. It's going to be built on a serverless stack. We're going to set up React website using Wing programming model. We're going to work with DynamoDB, S3 bucket, API gateway, and Lambda functions. We're going to develop and run your application locally, test it locally, both locally and on the cloud. And we're going to produce a ready-to-apply Terraform assets. And hopefully, also, we're going to create preview environments out of the box using wing.cloud. Some general resource that you can basically kind of look around while we're doing the work, because the way we're going to do this, I'm going to go through session by session. I'm going to go through the session pretty quickly, and then I'm going to give us 5 minutes, 10 minutes to work the session locally and to do the stuff. If you have more time because people are taking more time to other people, then it's a good place to kind of learn about in-flight, which is Winglang's most important core concept. There is a cheat sheet about Wing, and there's some language reference, and there's the playground. So that's the high-level kind of rules of engagement here. Any questions so far? Awesome. Thanks, Revital. So what are we going to do? What are we actually going to implement? So we're going to implement a flat file system, browser and backend. The file system is very kind of simple, I would say. It's a file system that only allows you to have one hierarchy of folders, and a folder can only have files. So let's see this amazing application that we've created. Now, the people here that are sensitive, have a sensitive eye for design, you would see that I'm not a really great React developer. But this is the Winglang application. Actually, a great React developer did help me do it, but I told them don't do it too good, so people won't ask me too much questions. So this is the application. This is deployed on AWS. And it has one option here. I can create a folder. Let's create the folder named folder1. And I'm adding a folder. Oh, I have a previous folder here also, written in Hebrew. I can delete it later. And inside this folder, I can create files. So let's do file1. And this is file1. Create a new file. If I go to file2, this is file2. I can create it. This creates files, and I can actually see the content of the file, as you can see. I can go back here. I see the folders. Folder.
Eyal, there is an ask to request the font if you can't.
Oh, yeah. Awesome.
Thank you.
Great. Is it bigger? Is it better? Thanks. So I'm creating another folder here. This is Hebrew. Someone, right? Okay. And you also, so this is shared. Everybody can join this link and start creating files and folders. And this is our amazing application of files and folders. And that's basically what we're going to do. Let's create another file here. You know what? Actually, who created the test folder? Let's see. Did you create a file? Come on, create files, guys. Interesting. I don't know, Rodrigo. The question of constraints of name. This is not. Let's just say it's not bulletproof. It's a happy pass application. If you do something outside the happy pass, I have the minimum possible code in order to create this. Especially on the backend, where this is. So this is a test file. I think spaces are okay. Spaces are okay. Okay, so this is what we have. Any question regarding the kind of the high-level application that we're going to build? So this is very simple. Now, the actual, I'll decrease the font size for a second. The actual architecture of the application in AWS is quite simple. We have our browser over here. The browser goes into Amazon CloudFront, a CDN, delivery network, and fetches the React static file, JavaScript file. Great, thanks, Shai. And in order to fetch the actual folders and files, it goes into an Amazon API gateway that basically activates AWS Lambdas. And these files basically, the compute services basically interact with the file storage, which is constructed from an Amazon DynamoDB and Amazon S3. So we have two S3 buckets, Amazon S3 buckets. One is for hosting the React application, the website, static content, and we're having the cloud front in front of it. And this one is basically kind of a module of the file storage. We're going to see it in a second. And then the API gateway connected to the AWS Lambda. Any question? It's kind of straightforward. Any questions so far? Great. So let's start after we understand what we're going to learn and what we're going to do here, let's start with why even fly? I'm comfortable where I am. So why are we actually doing this thing? So why do we exist? Why does Winglang exist? We exist because building a serverless application is hard. It's extremely hard. It's hard because of three reasons. One of them, you have to know the interfaces of your designated cloud providers. It's a discussion that I had with Revital and one of a potential kind of in an interview, a developer that is using serverless and the CDK, who was he liked his work. He was satisfied from his tech stack. He told us that 60% of his development time is spent wiring infrastructure together. This is crazy. We aim to remove this 60%, to eliminate that 60%. The second reason why serverless application development is hard is you have to test stuff in the cloud. And I think it was a couple of weeks ago, we met with a team, and we asked them about their local host setup, and then they explained to us how they're set up for the serverless, and it sounds really good. And then another engineer in the team, in the DevOps team, told, yes, but most people just push stuff into staging and then roll back when there's issues. So this is what's happening right now in serverless. We don't believe in local hosts. And again, this is what we're here to solve. And the last thing is, I think actually even one of the members here told me something about this. Microservices architecture is hard to set up, visualize, and operate. It's very hard to set up a microservice architecture. Very hard to understand how things are connected. It's very hard to run this locally. It's very hard to get the developer to onboard a new developer for this. And basically, kind of a classic startup VP of engineering once told me that I want my developer experience to be like we're building a monolith. And the serverless basically requires you to know so much stuff about it. So when it sums down to it, we have slow iteration cycles because of the complexity of the testing, and we have a lot of burden on the developers. Just if you take an example, kind of we'll see an example of how we kind of create a very simple application and what the developer needs to know in order to build it. Any questions so far? Awesome. So what is the solution for us? Is Winglang, an open source programming language that runs on the cloud. What does it mean that it runs on the cloud? So I took an example of another programming language, quite popular, used to be more popular, but quite popular, called C. And it doesn't run on the cloud. It runs on a computer. So you can write this software that opens a file and basically writes into a file. You can basically write this software in your Vim editor. And then, as you can see, it uses something called fopen, which is part of C standard library, right? So a file is part of the standard library of a computer. And then you can basically GCC and compile this software into your designated computer. So it can be the instruction sets of ARM64 or any other instruction sets. It can be ARM, it can run on Linux, it can run on Windows, but you have to compile it for that specific computer. So Wing is pretty much the same. The main difference is that instead of running on a computer where C is, it runs on the cloud. What does this mean? The first thing is we don't have files as the standard. I mean, it's not that important to have files. We do have files, of course, but our standard library consists of stuff that are available on the cloud. So an example would be a queue, or in the file, it will be a bucket, and we'll see that shortly. Instead of compiling it into x86 machine, we compile it into cloud. So a cloud could be AWS. The instruction sets can be something like Terraform or CloudFormation, or you can compile it to Azure or to Kubernetes, to a cloud running in Kubernetes. And the instruction set will probably be YAML files or Helm charts. So that's the main differences. And the benefits for basically having a Wing program is you can develop and test things locally using the Wing console and CLI. It's interoperable with your stack, so it is compiled into Terraform and JavaScript or basically CloudFormation or any engine depending on your platform. We embrace kind of cloud diversity. Basically, everything that can be done in Terraform can be done in Wing. It's that simple. I mean, I can use DynamoDB, and basically then my application will not be able to compile into a GCP, right? Like 20 years ago, when I was developing an OpenCV software, it only ran on x86 chip. So when I was including the OpenCV, which is a computer vision library, I couldn't compile it on an ARM machine. Now I probably can, but so I can still use stuff that is outside of can run on any cloud. But if it can be done in Terraform, it can be done in Wing. And we actually abstract in the cloud assembler. We're going to see this in a couple of minutes. There's automatic IAM permissions, the infrastructure wiring. You don't have to know the tiny details of how every cloud is basically, every resource has to be connected together. And it's fully flexible and customized. You can create your own libraries. You can import. You can use existing libraries. You can create your own platform. If you want this to run on your Kubernetes cluster, this is something that you can definitely do on your Oracle cloud. And in order to show kind of all those stuff, I'm gonna click on this playground demo, which will open this, of course, in the wrong place. So let me do. I need to convince it to go over here. Okay. Great. And I know we're going to go high on this. Let's take this full screen. Great. So is this big enough? Give me a thumbs up. Awesome. Great. So this is a very simple application in Wing. I wouldn't call it a simple application. On the left-hand side, I'm seeing Winglang code. If this is the first Winglang code you're seeing, congratulations. On the right-hand side, you're seeing the simulator, which is the localhost implementation of our cloud running in the playground. You have the playground link in the resources. And the application that I basically have now is creating two buckets. One of them is source, the other one is upper, and it creates an API gateway. And there is an event when a file is created on source, put the same file name, but with an uppercase content on the upper bucket. And there's a post to create new files. Well, let's see this in action for a second. I look at the source. I don't have any files here on the right-hand side. Look at the upper, no files. I go to the Cloud API. As you can see, I can interact with my application. This is something that runs on my browser, but it can also run on my machine, and we're going to see. I'm going to create a file. I'm going to call it Wing. I'm just going to call it Wing. And the body is hello workshop. So I've done not lowercase, but both of them. When I hit send, basically, I'll be able to see. I think when I hit send, hopefully, okay, I can see that the file wing was created, the file wing. I can go to the source. I can see, I can take a look.
I already want to click off. I already want to get this shit off the screen.
Okay, thank you. So I have a log workshop on the source, and in the upper,
Some condition. Guys, I'm gonna freak the bullshit, man.
Okay, so we're dealing with another call. And if I look at the upper side, I have Wing and I have a low workshop at uppercase. This is a very simple Wing application. And when you look at the amount of resources that are required, let's try to count the amount of resources that are required in order to build this. We need a cloud, that's one resource. We need, a cloud bucket, two of them, that's two resources. We need an API gateway. This is actually a Lambda function, right? So this is another resource. We need another Lambda function. So we have about 1, 2, 3, 4, 5. We also probably need to actually connect this Lambda function with this event. So maybe 7, 6, I would say about what, 10? Anyone want to guess how many resources are needed in order to build this software? You don't have to guess. I tell you that from the get-go. We can take a look over here at what will be the result of compiling this code into AWS Terraform. And there's 24 resources that you have to create in order to create this stuff. And it actually makes sense. You need the API gateway, and you need Lambda permission in order for the API gateway to run this Lambda function. Makes sense. You need an S3 buckets to host that Lambda function code somewhere. That makes sense. We need the SNS to pick up the notification, and we need the policy of the SNS that will actually trigger this. We need the IAM role, the IAM policy. This function, look at this function, for example. This function connects to, this function. It writes on the upper and reads on source. So we can see that it reads on source and writes on upper. So we can actually see that the specific function is getting the least privileged permissions that is required to run this. And the list goes on and goes on. There's permissions, there's the request, bucket notification. There's a lot of work here that I didn't have to do any work. These are all the resources that are required. If we go back and basically remove the write permission, this is basically not writing anything, and I look for the same IAM permission, automatically I will not need permission for the source at all because I'm not accessing the source. So all this stuff that is the wiring basically explains that 60% of wiring time that the serverless developer has showed us. So let's look at the IAM policy. As you can see, right now I'm only writing to this. Where is the to this bucket? And if I roll it back, it's going to work. So this is Wing. This is Wing compiled into. This is the Wing simulator. This is Wing compiled into AWS Terraform, and that's basically why we need Wing. Great. So it's nearly time to fly. So in this phase, we're basically going to install and verify the Winglang toolchain is working on your computer. Basically, just go over here and go over the steps. I'm going to give us about let's say 5 minutes, and then I'm going to check who will finish. People will have problems. Then please kind of open the Slack channel and ask for any questions, and people from the team will help you out. In high level, we're going to install the Wing toolchain with NPM. We're going to make sure that it works. And then we're going to, I can actually do this in a second. And then we're going to basically create a file and run it. So it's quite simple. Let's give it 5 minutes. Revital, you want to?
Yeah, I just want to make sure. Can you go to the, yes. So we need to go through the prerequisite steps and install all of those.
Right, thank you.
If we have any problem?
Yeah.
If we have any issue, what should we do?
So if you have any issue, go to the Slack channel to the workshop and just let us know, and someone will pick it up.
Okay.
So I'm turning off my video for. I'm turning off the sound for a couple of minutes, and I'm not sharing my screen. I'm gonna send this link again here for the actual step that we're doing, and we'll take about 5 minutes. Once you're done, maybe let's raise our hand so I see the amount of hands being raised, so I know that we're done. So thank you. 5 minutes, 7 minutes. Let's see how it goes.
Thank you.
Thanks. So I need to create a new folder. So let's do this. I do mkdir, creating a new folder. I'm going to cd to this folder. And then I'm going to start VS Code. So code dot. This will start VS Code here.
Yeah, this is something that we should be doing as well.
It's part of the getting started guide. So I'm just following it. Thanks for asking. So I'm basically doing this, right? I'm going through the, I already installed Wing. I have the latest Wing version. Now I'm going through and creating this folder. So all of you need to do this. Yes, start VS Code from this directory, create a backend directory. So let's do this. I'm going to create a backend directory. Let me enlarge the font as well. Is it big enough? Awesome. And I have a backend directory. I'm going over here, and I need to create a main.w file. So let me create the main.w file. The icon here indicates that I've already installed the VS Code extension. Great. I'm copy pasting this code over here. And now I'm gonna open my terminal. I'm gonna do wing. This is the version I'm currently running. I'm going to wing run backend main.w. And the result, let me split my screen. It's like this. The result, I haven't saved. So once I save, the result is this queue, this cloud bucket and cloud counter. And if I send messages, so this is, let's get this a little bit bigger. Let's get this a little bit bigger even. So now I'm clicking on the cloud queue. I can click on the bucket and click on the counter. I'm clicking on the cloud queue, and I can push messages to the queue. This is a message. Now, when I push the message, I'm going to push the message on this queue. This queue has a consumer. The consumer will increment my counter. The counter right now is at 0 value. And we'll create a key dash this value, the value of the counter. And then we'll put the bucket file name key.0 with the body of the message. This is a message. This is message number 1. Let's do like this. And let's do, this is message number 2. And if I go to Cloud Bucket, now I have 2 files over here on this key. And as you can see, this is my first application that is running. And this thing, I can actually, basically, I can create another terminal. I can take this application, Wing, compile it into TF AWS, backend Wing, main, and this will generate Terraform file for me. Which, I mean, as you can see, these are the Terraform files. So all the stuff that is needed in order to do this. There's a queue. The queue is an SQS queue, the default one. The bucket is S3. The counter is a DynamoDB table. All of this is available. Going back to the workshop, that's it. You can push messages to the queue and observe. Anyone having trouble running this flow? If you do, just ping us over the Slack channel. Someone from the core team will help you. If we're fine, we can move back to the next chapter in this tutorial. And the next chapter is prepare for lifter. So basically what we're going to do in this is we're going to write our second Wing program. So when we're going to get to know the Wing Cloud. Sandy and Shai, you can raise your hand. Thank you. Great. So very quickly, I'm going to go over this instructions, and then again, we're going to give you another 5 to 10 minutes to run them. So we're staying in the same flow, in the same workspace, and I'm going to replace my main.w with this code. So this code basically has two parts. There's the bring. This is how I'm using, I'm actually kind of using the standard library. This is our import statement. I'm bringing cloud, I'm bringing HTTP, and I'm bringing expect. And I'm creating a new cloud API. This code is pre-flight code. We haven't touched this yet. In Winglang, and there's a lot of people that maybe don't know it, in Winglang, there's two different types of context for code. One is pre-flight code. This is code that's going to run during compilation. It eventually is going to compile into provisioning engine, whether Helm, Terraform, CloudFormation, Pulumi, whatever your target audience is. And we're gonna see later the in-flight code. So any code that doesn't have the in-flight modifier is basically pre-flight code. So I'm creating this API gateway. This will turn into a provisioning API gateway, and then I'm running a test. Test says get hello. I'm going to go to the API URL. I'm going to look for the hello, and then I'm going to expect that the result status will be 200, and the result body will be React Wing workshop. Another thing we're noticing here that we don't need to do await. People coming from TypeScript are usually doing await on every kind of network calls. In Wing, if you're running on any flight, most of the time it's an asynchronous. You're running asynchronous code that needs to wait. So basically, we don't need to call await, and the Wing compiler automatically puts the await inside the code. So I'm copy pasting this. Okay, so I've copy pasted this over here. Great. And the next thing, let's run this locally. So I'm going to do wing run backend main. This will again open this view. I need to remember to save stuff. If I don't save it, it doesn't show up. So now I have the cloud API here. It doesn't do anything, as you notice. No one is actually running it. But I have also the test on the left-hand side, as you can see. So I can go over the instructions over here, which basically indicates this thing, and I'm going to run the test from here. Let's run the test. And the first thing I'm saying is the test failed. And it fails because 404 doesn't equal 200. The test was expecting result status to be 200, but the result status is 404. Now, can we fix this code so the test passes? This is where I leave you with 5 minutes. Get to this point and fix the code. There is a solution here. You can click the solution and open it. And then we'll go, after these 5 minutes, we'll go over the different options that we have for running tests. Any questions so far? So I have a question here. Can you show how you can target the variables file for TF multi-account environments? Okay, so can you paste this, Christos, can you paste this thing inside our Slack channel? We have a designated Slack channel, and someone from my team will pick it up. And then we can start the discussion over thread. Thank you. I'm putting myself on mute again, giving us 5 minutes to make the test pass. Maybe even 10 minutes, we'll see. Sandy, last time you were first. Let's see if it still is going to happen. Sandy is not a Wing developer, so but I'm putting you on the spot, Sandy. Awesome.
I can see. Thank you. I'm trying.
Awesome. So for those of you who've been joining later, the first step for you to do is go over the nearly time to fly. I'm going to share my screen. Let's. The first step for you to do is quickly install using NPM. If you have Node.js already running and VS Code, quickly install the Winglang application, and then download the VS Code from the marketplace. And you can use the following code to make sure that your application works running this command. The rest of us are right now writing our first Wing program, where we have a cloud API. This is an API gateway. And we have a test that is failing. As you can see, this is the failing test. And we want to make the test pass. So we need to look at the documentation of Cloud API and understand how can we create an API, an endpoint for the API that says hello and replies React Wing Workshop with status 200. This is basically what we're doing. If you're done doing, if you have any questions with the setup, with everything, you can just go over to the workshop main file, join our Slack channel, join our Slack workspace, and go to our Slack channel and ask questions there. We can help you. You can also ask questions here, and we'll try to help you as well. Awesome. I'll give you a couple of more minutes in order to make the test pass. And if not, I'll show you. All right. So it's time to solve the puzzle. Again, I have a test here. Get hello. The test calls this URL.
We need to see your screen.
Thank you. Thank you. I am showing the screen. I'm seeing the screen. 1 second. Great. So what do I have here? I have the console. I have the Cloud API. I don't have any routes here. I can see this when I click here over here. Nothing pops out for me. You will see this in a second. And I have this test here. I can run the test. This will run this code. This code is actually getting the URL of the API. Let's log this thing so we can see this. Great. Let's clean the logo here. I'm cleaning the logo on the left side, and I'm running this again. So now this is the URL of the API, as you can see. And then the deep equal fails. Thank you, Sebastian, for this expect syntax. It fails because the status is not 200. So I can make it this test pass, but in order for the test to actually pass, I need to also return a body, React Wing Workshop. So how do I do this? I go to API. I hit dot. Now, when I hit dot on API, I have get, delete, basically all the kind of HTTP methods here, path, post. Because we're doing get here, I'm going to create a get response. So I'm going to do get, and I'm going to give it the hello. This will match the code here. And then I need to basically supply it with a function. This will be an in-flight function. It's going to run inside the Lambda. So I need to write in-flight, the in-flight modifier on the function. This in-flight modifier is super important. It basically means that the code I'm going to write within this closure is going to run in the cloud. All the code that I'm written here, the test is unique, but all the code that I've written here is running during provisioning. So I'm creating this endpoint in provisioning, and I'm connecting this endpoint with a Lambda function in provisioning. But the code inside this in-flight function is going to run in the cloud. We have a type in inference, so I can state the type here. I can say that the type that this function needs to return is cloud.api response, and I'm getting a request here. I can do this request cloud API request, cloud API request. But this is cumbersome. I'm not going to do this. I don't need the request for now. I don't need this thing. Basically, I need to return something that qualifies as an API request. And as you can see, the compiler tells me that I'm missing status for an API request, as you can see. So in order for the test to pass, I need to send a status of 200, status 200. Now I can rerun the test. Let me save this. The first thing I'm seeing is our update here. Once I save, again, the hectic feedback, closing the loop of iteration cycles. And I can also go over here and actually on the right side, actually activate my endpoint. There's no body because I haven't sent the body. I can actually run the code from here. Let me clean the logs and run the code from here. I have this URL. But right now, it tells me that the React Wing Workshop is not equal to this. And this reminds me that I haven't updated my version because this thing is already fixed by one of our community members. So the React Wing Workshop does not equal the fact that I don't have a body. And I can also see this when I go take this URL, just click on this URL, and go to hello. I don't get a body here. So let's change this to a body. And let's do, I'm writing code on the other side. Body, React Wing Workshop. When I resave this, the application kind of automatically recompiles. I can clean the logs here. And if I go to test this on my browser, now I should be seeing React Wing Workshop. Let me get this a little bit bigger. So this is React Wing Workshop when I'm going to that URL. If I run the test, I'm hoping for the test to pass. So this is how I've basically implemented the very simple API gateway. And the nice thing about the fact of what I've done here is I can take this code over here. There's a bunch of options for me. We already seen that I can call the endpoint from within the console. I can also call the endpoint from outside, from a browser using curl or anything that I would like this. But I can also run the tests within the console, as we've seen like this. And the last option that I have, and I'm on the right side right now, I can just run the test, wing test, backend, main.w. There's a single test here, but I can run it, and it's going to run the test. So this is how I'm going to run the test during my CI. Basically, and as you can see, get hello, this is the test name, and the test passes, and this is the log that we have in the test. And I can write more tests. I haven't mocked anything, by the way. It's kind of like an end-to-end test. I'm actually testing my API gateway from its URL. This is important because this means that I can also run the same test in my AWS, in my Terraform. We might have time to see this later. I can do this right now. Wing test, backend, main. And instead of running this on the SIEM, which is the default, I give it a different target, and the target will be TF AWS. Let's hit enter. Now what happens behind the scenes is that it compiles this simple application into Terraform on AWS. It does Terraform init. It will do Terraform apply. It will run the test and do Terraform destroy. So we're actually going to see this, and this will basically indicate to me that this application is actually, that the simple application actually works in my production-like environment. So that's it. So this is our hello world. And I see that we have a question: which runtime do the in-flight function use by default? Do they support multiple runtimes? So who knows from the team? I mean, I think we have the Node.js the default Node.js runtime. What is it? Do you know? Oh, you're laughing. So do you even know? You know the answer as well?
18.16.
So that's the default Node.js runtime. And can we set it up? Can we change the Lambda function? Can we change the actual? I mean, do we have a node? I would expect to have this here, right? As a parameter to this function, right? To change the node runtime. I'm not sure it's supported. So
as Hassan said, through a platform is probably the way to go. But
awesome, great. I think it's possible to change it, but I'm not sure. I'm not sure whether it's possible to do this within this API. If not, we need to open a ticket. This is something that we need to add. Because I think when you're creating a new cloud function, you give it an in-flight, I think you have an option for, yeah. Okay, so I don't see it. I don't see in the options that we have. No, just environment variable, role retention, memory. So no option to set the runtime yet. So something we need to do. Okay, so that's a good question. Right now, you can do Lambda function only with Node.js. So the question by Ashish is, do we only support Node.js? Right now, the Lambda function is already Node.js, but you can also run workloads. And basically, that will be to run containers. You can run container in any language. So if it runs in a container on a Docker image, it can run on Wing. The default behavior will be to run it inside Kubernetes. It's not going to be part of this flow, but it's definitely possible. But Lambda function, right now you need to do Node.js. And again, open a ticket. This is I know some people would love to write code. Great. Awesome. Our next phase, unless there's any other questions. Great. So what is our next phase? Okay, so till now, what we've done, we've kind of played around with an API gateway. We saw how this works, but we're here to do React. So in order to build a React app, you need to have a React application deployed on a static website and Winglang. So let's basically go over the flow and how to create this. I'm going to go over this really, I mean, this is a step-by-step guide. I'm going to go over this really quickly. I'm inside the same Wing workshop, and I'm copy-pasting this code. This will create a React app on my machine. Can increase the font, awesome. This will create a React app on my machine, and we'll start it. So I'm basically copy-pasting this code and running it. It will run it's going to download, it's going to create a React app under my client directory. Then there's a bug in the, it's gonna add this npm package, and then it's going to do npm start. The result of this is not related to Wing, it's just making sure that we can run a React app. If you have the time to do this right now while I'm doing this, this would be great. And the thing that we're going to do later is how this React app, we can activate this from within Wing, and not from npm start. Let's clear this thing here a little bit. All right, so it's about to end, and now it starts the React. Okay, it does another template dependency. Okay. Yes, I want a different port. Sorry, I want a different port. And starting the, okay, and this is my React app on the left side. So this is not written by us. It's create React app, create an application, and now we have this over here, and it automatically kind of out of the box works with hot reloading and all the lovely stuff that the front-end developer have and back-end developer don't until now. So let me hit the Control-C. Let me close the screen, and let me go back to, let me move this screen, and let me go back to where we are right now. Now, instead of running this React app, so look at my folder. I have a backend and a client. Instead of running this React app from the npm start, I'm going to model this React app inside Wing. So how am I going to do this? I'm going to go into my main.w file. I'm going to delete the stuff that we have right now, and I'm just going to have this thing. So I'm bringing the external, this is the EX, it's an external namespace that we have. I can actually do npm install React app, probably it's about to be outside the external. The external is kind of a temporary place to put stuff. So I'm creating this new React app, and my project path is the client. So as you can see, the client, I'm inside backend main file. So this is my client app. Let's also set the local port. Let's put 403. And now I'm going to do like we did before. Now I'm going to go over here, and I'm going to do this thing. I'm adding the browser none ahead of the React, just so it won't open the React app like it does when you're not doing it. So every time I'm recompiling React, it will open the browser. I don't want this. So now I have a React app in here, nothing to it. But as you can see, there's a link, and I can go over the link. And the same stuff that we've seen before works. And if I go into the source file and change learn React now and save this, this happens out of the box. So this is not, we haven't changed anything with Wing. We're just basically making sure that even if I run the React app within a Winglang backend, in my local host, it will behave as I would expect for fast iteration cycles. So that's pretty simple. Now, what we want to do, we want to be able to pass configuration between the backend and the frontend. So this can turn a little bit tricky. If I go over the public file, I see that I have a Wing.js file. As you can see, it's empty. This Wing.js file is automatically generated by Wing. If I go to React add environment, I'm going back to main, and I'm saving this thing. And let's do message font, please. This is something that's happening a lot here. So let's once I save it, it automatically recompile this application. And then you can see we have the message font. So automatically, as part of the flow, when I'm changing the software and saving the software in Wing, this Wing.js file is changing parameters. And this is important because I'm going to use the fact that this is happening all the time in order to pass information from the backend to the front end. So let's do this. So in order to do this, I need to include this script. I'm going into HTML, this HTML file. I'm going to copy it. I'm going to look for a good place inside the head, just over here. And now I'm basically importing it. So if I go here, I don't see any change, but I'm importing it from here. Now, the second thing I need to do is use this information. So window.wing.have title or learn React. I'm going to go to the app.js file, and I'm going to replace this with this thing. And I'm going to save this. Now I'm saving. Automatically, it goes into Wing React. So what happens here? The code here, if you're not familiar with JavaScript, the code goes into the title. If the title doesn't exist, if this is undefined, it will do learn React. So let's create a title over here. I'm going to save this. And now it automatically changed on the fly. So this is what we're seeing right now is hectic feedback between the backend and the front end. I can change my software on the backend and on the front end, and everything automatically, magically is working, basically passing information. So that's what I've done. Any questions so far?
Yeah, you were muted.
Awesome. So learn React with Wing. This is what we're doing right now. So super cool. At least that's what someone said when I was muted inside this office. But let's make it more helpful. Why do I need to pass parameters? I want to pass parameters because I want a single container for my backend and my frontend to be connected together. We all know this. We don't. There's a lot of environment variables, configuration files. To connect the backend and the frontend. Everybody that's done the full stack development is familiar with the 900 ways you can connect your backend and frontend. I'm assuming we'll have 900 ways to do this as well in Ring, but they will be extremely better. So in order to do this, I'm gonna get the title. Instead of getting the title from the configuration from an environment variable, I want to get the title from calling an API gateway. So to do this, what I'm going to do is go to main.js and basically create an API gateway. We already created an API gateway before. Right now, I'm creating an API gateway with Core. Core is cross-origin resource sharing, and I'm just setting this true right now. Now, I want to copy-paste this API, the environment over here. I want to save this here. Now, if you take a look at my files, my Wing.js file, it also includes this thing. Now, this will change every time that I save, because every time there's a new port, 6144 and 6164, I mean, a different number. Great. I've done this. And now, let's create a title. So we've already done this before. I'm going to do API.get. When someone asks for a title, tell a long for the Wing API. Very easy. And now I need to do some JavaScript React magic, which is kind of simple. I need to create, I'm using React hooks for this. Basically, I'm going to call fetch on window API URL title and set the title. And React will do the rest. So this goes into app.js file. This is this file. I'm just going to override it with this new code. Once I do this, I have a hello from API. Now this is done during the URL. I can actually, if I go into my backend, into my backend, I can do like this, and I can actually say log someone called me. Let me save this for a second. I do here, and if I go into my console, someone called me. And if I hit the let me clean this for a second. And if I hit the refresh, the website will get the title again, and someone called me again. Why is it calling it twice? God knows, something with React, some kind of bug, I don't know. I don't know, but here it is. Let's call it a bunch of times, and I can see someone called me. So this is the information that's actually coming from the API gateway. So now we have a React website connected to an API gateway, and I can just go and deploy this React website into production. I can do wing compile Terraform TS, and I can do Terraform init, Terraform apply inside this target file, inside the backend target file, main TF AWS. I can do Terraform init, Terraform apply, and now I have a web page that's running React and basically behaves the way we've just seen. That's simple. Now, I'm not going to give you the time right now to go over this because I want you to do both stuff together. So I'm going to go to the next workshop really, really briefly. The next workshop is setting up the preview. So what we're going to do in this workshop, we're cruising. Let's set up a preview environment for every PR using wing.cloud. Should be quite simple, but it's a lot of work. I mean, there's a lot of work we need to. So I'm just going to go over. No, actually, yeah, let's do this. I'm just going to go over the instruction really, really fast. I'm deleting the Git file and Git ignore. I'm creating my own Git ignore. And the reason I'm doing this because I want to create, in order to set a pull request automation that will create preview environments, I want to have a GitHub repo on .git ignore. Great. And I'm doing git init. I'm doing git st, git add dot, git st, and I'm doing git commit, initial commit. So this basically I generated a local repository. Till now it was a temp directory, now I have a local repository. And the next step for me is going over GitHub onto my account. Sorry for rushing this thing, but it's just instructions that you can create follow. I'm going to create a new repository, and I'm going to call it Wing React Workshop. This is good. I'm going to create an empty repository because I'm going to push the information to it. Let's do this. And I'm just going to copy the code from here to push my existing code over there. So I'm doing this. I'm following this thing over here. And the next step for me is creating a backend wing.shell. This is so again, what we're going to do, and maybe I haven't explained myself properly. Once I create a GitHub application, I can connect this GitHub application to something new that we're building called wing.cloud. And wing.cloud will automatically create preview environments on the floor, on the go for you. So in a couple of minutes, you can do these two steps together. I just want to quickly show you what's the result. In order to do this, I need to basically use the backend wing shell. Let's create this file. This is the backend wing shell. And this just tells Wing how to npm install the client side. something we can probably solve in a better way, but this is something we can do right now. We have to do right now. And let's commit this to my repo. And if I go to my repo and I hit the refresh, now I have the backend. I have a main file and a Wing shell, and I have the client with the code that we've seen before, all the stuff that we've seen before. Going back here, I'm going to production wing.cloud.io. Do this. I'm logging in. Now this is a temporary URL for our environment, and what I'm going to do now, I'm going to connect the production Wing Cloud into my repository. So I need to give this application the right repository permission for the new React Wing React Wing React workshop. Great. I just gave it the Wing React workshop. Now I save it. Once I save it, I close this thing probably. And look for the Wing React workshop, and I connect this.
Yeah, can you increase the font, please, again?
Sure. Thanks, man. So what I've done, I've connected. This is going to following this instructions over here. I've connected my repo into the GitHub. I pressed the add button, connected the existing repo, gave permission to that specific repo that I've created. And now, if I go back here, I can see that main is building. So while we wait for main, I suggest that you guys start going. You know what? Let me also create a pull request with another version, and then we go over to your site. So I'm going over here. Let's create a pull request. Let's go over the workshop. No, this is not the workshop. Let's go over here. Sorry. Let's go over the workshop. I'm going to the backend, and I'm going to change my main. I'm going to do this change from here, and from API, but this time inside from API PR. Pull request. Okay. I'm going to commit the changes, but I'm going to create a new branch. So if you're familiar with Vercel preview environment, we're going to see exactly the same. I'm going to create a new branch, and I'm going to propose this change. In the meantime, I see that my main is working, and we're going to observe it in a second. And I'm going to create a pull request. So on this pull request, what I'm expecting to see is that the Wing Cloud bot, or I don't know, application, will add a comment that they're building this comment here. So basically, we're deploying your preview environment. I can take a look at the existing preview environments I have for main, and as you can see, I have the React app URL. I can press the React app, and I can see that I have default value here. And there's some traffic problem that we have right now with building this. It's going to take a little bit more time. I was supposed to wait a minute before clicking on this. So let's see if it's fixed, because the default value is the one that, okay, so hello from the API. So this is what we have in the main branch, as you can see, right? If I go back to the conversation, I see that this thing is still building and deploying. And I suggested what you're going to go right now is go through the two stages, the preview and the, I'm going to do this. Let's do the React one to create the React app and the preview. And I'll give us 10 minutes for this, and then I'll show you how the preview environment looks like. I'm going to post those two links in the Slack channel. Ashish is mentioning, is asking a great question. So the Wing Cloud part is not necessary to deploy your app, right? No, it's not. So I can actually I can actually kind of wave my hand, but let's do this while I'm going to present my screen for those of you who want to check it out. And I'm basically going to do this. I'm gonna compile this to Terraform, the code that I have right now. And now I'm going to see the backend target main TF. I'm going to Terraform init. And then I'm going to do apply. I'm going to Terraform apply. And this will take, because I already have AWS set up for my, let's take a look at what's the result here. This will create a lot of stuff because I have I need to create a CDN. I need to create S3. I need to create connection between them, distributions. There's a lot of work under the hood. I'm just going to give it the option to do this. And this will create, using Terraform and AWS, not connected to wing.cloud, this will generate the application that I've written in AWS. And we can actually, I have the console. Once it's done, I can have the console and we can look it up and see how it works. So let's wait for this to finish. And on the wing.cloud part, if I go over here, I can see that I have React app endpoint in my preview environment while this is running. So this is my preview environment. This is my pull request comment. I have a preview environment here. I can look at the React app, and I can see that it's from the pull request, as you can see, from the pull request. And I can also visit the console itself and basically play around with this application. This is the application in production. I can actually go to the Cloud API and get the route and actually see this is what it does. Or I can use basically the result of the application. So for any change I'm going to make, I can do this. I can do something cool like, might take some time, but I can do something cool like, let's go to the workshop. Sorry, not the workshop. Let's go to the Wing React workshop, to the backend. Let's go into main. I'm going to try to write code on the fly here. I'm going to do let bucket equal new cloud bucket. And instead of, and I'm going to take the information. So I do bucket.get title. Yeah, let's do like this. Let's let's commit these changes. I probably need to do bucket set object. So let me try the playground for a second. This is still running, so I'm waiting for this to run. Add object, okay. Okay, great. I'm going back here. I'm using the add object API in order to set the default bucket title. And I'm going to commit these changes. I'm going to read the title from here. I'm going to commit these changes into a new branch and create a pull request. Awesome. This is still running. Terraform takes some time. Hopefully it will finish soon. So the short answer is it's not necessary to deploy your app. You can deploy this as an open, you can deploy it with your own set of tools. Yeah. And I'm waiting for the React workshop to open. In terms of time, we're not going to be able to finish this entire stuff. So the next stuff that we have on our plate is creating a module. So I'm going to create a module. I'm going to which we're not going to do. It's basically, we're going to create a flat file system module. We're going to basically implement this. You can go over this. There's some exercise given here, and it basically allows you, it creates a bucket and a DynamoDB service. And then we, wrapping it all together is basically connecting the UI that we saw in the beginning, the AWS UI, this thing here, connecting it to the application. And that's it. We have another workshop in a month that we're gonna build a serverless workflow powered by AI and Bedrock. Yeah, awesome. I understand what you're saying. Ashish, let's take this offline through the channel and let's pick up this discussion. I think it's a valid discussion. If I go back to my React, I'm waiting. This is done. If I go to the React app, I should be seeing my default value of the bucket. Might take some time. So this is the default value, but this is not the default value of the bucket. So let's wait a little bit until the DNS will resolve. So I need to wait more than 1 minute. This is a known bug for us. Okay, this is the default bucket title. And if I go to the console, what I'm trying to show you is that I can actually go inside the cloud bucket and see the title here. And I can download this file. Let's open this file. We open a different file and say this is a dynamic title coming from my computer. I want to save this file, and let's delete this thing. Let's upload the title that I've just created. I need to find it, of course. I'm pretty sure you can see what I'm doing, but I'm just trying to find my title file. Maybe like this. Here
You deleted the file, right?
What?
Oh, I thought you deleted the file.
I deleted the file from the bucket in production, but I've just uploaded this, and I uploaded the wrong file. Oh, I know what the problem is. I need to do title text. So it's not going to work. It's going to work, but not as much as I expected it to work. So if I go over here and refresh, let's close this thing. Yeah, I screwed up the file itself, so it's not going to work. I needed to create a title.txt file, so the content will be the same. Oh, I see my Terraform file failed because I already have a log group like this. So I have some problem with my Terraform file, so I won't be able to show this. And the title.txt was a complete failure because I didn't create the right one. So I'm sorry about that. In terms of time, we're reaching the end of time. I think someone had a couple of. I think someone had a question or a comment. Shai Bear.
No, it wasn't a question or a comment. I can just give me 10 seconds in the end, but let's let people actually ask questions. Yeah.
Okay, so again, thanks, Shai. So as we said, that there's another part of this exercise that needs to be done in basically creating the model for the file system and then collecting the React code with it. But this was kind of I think we need to kind of understand the timing, whether we need more time or have less content. I would love to reach out to some of you and get feedback about this. Shai, do you have something to say?
Yes. So first of all, thank you, Eyal. It's been great. I really enjoyed the workshop, and I hope everyone else did too. we're trying to raise awareness for this project and have more people hear about it and join the community and experience all the good things and give us feedback. So I just posted about us on Show Hacker News. It's here, one of the first ones now. So if anyone is interested, we'd appreciate an upvote to help raise awareness. And that's it for me.
Thanks. So going back here, as I've said, I know this before, you haven't done the file storage, you need to do chapter number 6 for this.
Share yours.
Yes, of course. Sorry. So we need, in order to do the file storage, you need to go through chapter number 6, which is a nice chapter. It also does kind of you create a module, and as I mentioned, next month we'll be using Amazon Bedrock. Basically, kind of take files and use LLMs and connect basically a serverless flow that basically takes the information and use Amazon Bedrock's LLM foundation models in order to have fun with it, I would say. So hopefully you'll join and spread the word. Thank you very much for your kind participation, and I'll see you next month, or even better, I see you next week in the Slack channel. Thanks.
Thank you, Eyal.
Thank you.
Thank you.